Hello and welcome to Makers.dev, episode number 111. Chris, do you know what a rep unit is?
A rep unit?
Or rep unit? Rep
Nope.
unit? I'm not sure how to pronounce it. What if I told you that 111 is an example of a rep unit?
I mean, is it numbers repeated multiple times?
It's a number with all the same digit. That has a name, and it's called a rep unit.
There you go.
That's it.
I mean, it makes sense. You have a unit, which is repeated.
Yes.
Sure.
Repeated unit. That's exactly right. Did you also know that 111 is prime in an infinite number of bases? Do you want to take a shot at trying to name one of the bases in which 111 is prime?
2?
2. Yes. 2 is one of the bases in which it's prime. Also 3, 5, 6, 8, 12. And it goes on from there. And it was interesting thinking about, 1 would be the most common number in all the bases. The digit 1 would be in every single base. Yeah. So if you have some sort of arbitrary test you're doing on numbers of 111 is going to be a number in a lot of those bases. So I thought that was cool. Those are my fun facts about 111 for today.
Interesting. Cool. I like the second one. Yeah.
Cool.
The first one's fine.
That's exactly the reaction I was going for. That's what I go for with these facts.
Yep.
How are you? How was your last week?
I'm doing all right. I have my new replacement unbroken computer.
Oh, congratulations.
So I got that. It is running. I could talk about, first, I'll talk about that. I'll talk about how Windows is silly. But first, I have a podcast recommendation. I want to make sure I get this in. Adam Wathan and Ben Orenstein started a new podcast called Hackers Incorporated. And the first 2 episodes are great, but the third one is with Jason Cohen, and it's excellent. They talk about specifically the talk he did at MicroConf, the Designing an Ideal Bootstrap Business, which is a classic talk.
Yeah.
If you haven't watched that one, go watch that one first, and then listen to their podcast, because they talk about how it applies to both Tuple and to Tailwind, and also like updates, since 10 years ago or whenever he gave the talk. So yeah, Hackers Incorporated, good podcast.
Love it. I will check that out, and we'll have a link in the show notes if you enjoy podcasts. Yeah, that Ideal Bootstrap Business talk, I feel like I need to watch that once a year. It's so good and so condensed, and yeah. I wish I could say more about it, but it's been too long since I watched it last. So yeah, I'll check it out. Talk to me about the computer. What?
So I got it.
Is it everything you hoped it would be?
I don't know. So Windows, I purposely bought a Windows computer because I don't have Windows, and I wanted to run a few games that are Windows only.
Like Hogwarts Legacy.
One of the first questions my wife asked was, does that mean we can run the new Harry Potter game? I was like, actually, yes, it will run that. So we're probably going to do that. But yeah, Windows is weird for a few reasons. One, the default setup is like, it has a bunch of news stories automatically populating and like the widgets and stuff. And there's actually just a story today about how for someone those were populating with like tabloids and stuff.
Yeah.
And it's like, this is not the purpose of an operating system.
Yeah.
And so turning that on by default is like, anyway, so I spent like an hour turning off all of that, plus the like, do you want to share my information with all sorts of different things? And it like had apps installed like WhatsApp and TikTok like automatically. And I was like, why? I don't want that. Yeah. Anyway, so it has a bunch of bloatware. Got rid of all that. I got the Python, like the Jupyter Notebook thing running, and it all works, but the GPU is running about 3 times slower than I expected it to. And I messed with power settings, and I messed with, like, I turned off Windows Defender I excluded all the Python stuff, and it's still just not working quite right. So I think I'm just going to dual boot Ubuntu and do it that way. So I'll still have Windows for games, but yeah. I have seen benchmarks that show Windows can run, the deep learning stuff just as fast as Linux, or nearly as fast, but I could not get it to work.
That's really interesting. That's surprising to me that the driver integration on Linux would be tighter than on Windows for a GPU. It seems like it should be reversed.
Yeah, I did a bunch of research, and it seems like there's probably just a setting somewhere that is throttling stuff down, or like the Windows Defender one was interesting. My Python was taking forever to boot, and it was because Windows Defender was like flagging it or something. And so I just excluded it, and then it took less time to boot, but still took a long time to run. So there's something somewhere that I don't have the patience to go figure out. So I know how Linux works.
You know that you can already do it on Linux. So yeah, that makes sense. That makes sense. And then, yeah, dual boot, you still get the advantages of both. That's exactly what I did with my PC that I originally got for video editing, but then the M1 came out and I realized, oh, the M1 does the thing that I wanted to do on the desktop, like about as fast, and it's on my laptop. So I stopped using the desktop. But yeah, I dual booted, and for getting work done or for getting video editing or running FFmpeg commands, Linux just makes a lot more sense to me. I can SSH into it, and it's very familiar tooling. And then, yeah, for playing Hogwarts Legacy, you got to have Windows. So,
Yep.
Yeah, that was nice. Interesting. Like, I'm so curious about the internal process at Microsoft that creates the sort of first boot experience where it's trying to distract you. It's like it's like if you bought a drill and the drill was, when you picked it up, it was chatting with you about the weather or trying to tell you jokes, and you're like, what are you, I'm trying to use you as a tool. Like, what are you doing? You're getting in my way from using you as a thing. You're just trying to steal my attention, and that doesn't seem healthy, and it doesn't seem like it's healthy at a company level that they're making stuff like that. And I'm reminded of my surprise that over the last few years, it seems like Microsoft has been reinventing itself and becoming cool again. But there is still this legacy Windows that makes things like the desktop Windows experience that just don't make sense. It could be so much nicer. Why is there TikTok installed on it by default? That doesn't make sense. Why is it showing me tabloid news stories? Like, what's the purpose of this? I like what went into those decisions to create that experience. It's something I'm curious about.
Yeah, and I do know like manufacturers, hardware manufacturers can decide like what goes in the default Windows experience. So like it's an MSI computer, and so there's MSI drivers already installed. They can also do things like add bloatware, and so it may have been MSI actually that decided. I don't know. I kind of doubt it because I guess I kind of doubt it, but yeah. Yeah.
Is it some sort of deal where maybe TikTok would go to MSI and say, hey, if you include TikTok, we'll pay you this much money per computer you ship?
Or directly to Microsoft. I don't know.
Yeah, gross. I want my tools to just be their tools. Things like that really, I'm really glad Linux exists. What a better world we live in that we have Linux. In that story you mentioned this morning from Hacker News, they talked about how the design team is running a lot of the decisions that go into the Windows desktop experience. And a lot of those designers don't actually use Windows because they're designers. So they use Macs.
Interesting.
So there's kind of this disconnect of that the people actually using it aren't the people thinking about the decisions of what an actual good, useful experience would be. It's just people who want things to look pretty. And I could totally see on a tech demo of a PowerPoint slide or something, if you saw, look at this, a really pretty news bubble, and it's styled in this new fun way. I could see that as something a designer would put in there because, they just designed this cool looking bubble and we got to put something in there. Well, I don't know, let's put news in there, I guess, without thinking through that you're trying to solve a problem for a user, and then it sort of becomes disconnected and you have this gross distraction machine. Yeah, I think that makes sense for me. Any comments on that? I'm about to change the subject.
No, go for it.
Okay. What are you using this computer for now? This is for, I think, the project of trying to reverse engineer images to the descriptions. Do we have that up and running, or are we still waiting on the Linux thing? How's that going?
Well, yeah. So this last week, I was also doing my advanced linear algebra test. And the whole time I was like, why am I spending time on this class? But I got it done. And I will say, like, I don't really like theoretical math stuff. I learned that about myself. However, when you finally understand the problem and you solve it, and you know that you answered everything with like all the nuances that you're supposed to, and like you get it, there is a certain gratification to that. It's kind of like programming in that way. So that happened on one of the three problems. The other two were frustrating. And so but I can see how if you can, you can solve something in a nice, clean way, and you fully understand it, like it's actually gratifying. But it.
Can you explain at a little bit deeper level what the test was on?
Boring stuff. It's
okay.
It is using, so these last four sections, the class is grouped into 12 sections, so 3 groups of 4. These last 4 were finally like implementing things that we learned about in the first 4 sections.
Okay.
So in the first 4 sections, imagine building blocks. So like all these little building blocks of things. Now we're actually talking about the algorithms for how to like solve systems. And so that's kind of interesting. So it's like you have this big system. And so say the example given in the notes is like sound on an eardrum, and you want to solve for how that eardrum vibrates. You could imagine breaking it up into this huge mesh, and then you have a force acting on that mesh. And then how does that actually like work? And it turns out you can solve it with linear algebra. And if you just try to solve it naively, it's like, like will take hours and hours and hours for a computer to solve it. So then you say, okay, based on all we know about linear algebra, how can we make that faster? And so it actually is a lot like gradient descent. So it's a lot like neural networks. You basically, you pick a search direction and you go in that direction, and then you can prove that if you go long enough, you can like make your error infinitely small. And so you just have to pick how far to go. And it's for computation. So it talks about like, okay, in a computer, you have 32 bits for a float, or 64 if you're in double precision. And so you can't go infinitely far. And so you might as well stop when you know that your floating point error is going to be like larger based on the algorithm you're using than the actual error. And so all of that's kind of interesting. But in practice, what you do is in programming practice, you just call a solve command and it does all that in the background for you. Right. But now we know what actually happens when you call solve.
Sure, you're understanding it at a deeper level. That's so cool that you can solve that problem of mapping how an eardrum is vibrating, and you map a mesh to it, and then you I guess have individual points of how much they're moving when a sound is produced. Oh my gosh, that sounds so complicated. That's so cool that you can solve that with linear algebra.
Well, and we do this sort of classic physics thing, which is like pretend the eardrum is a square, like, and so it's vastly simplified from the actual problem, but it's like an external force acting on a square mesh is what we're solving. Yeah.
I'm still very impressed. That's some complicated mathematics, and that's really cool that you understand it at that deeper level. Which reminds me, I'd like to know how ChatGPT works.
Yeah.
At a lower level of, here's what I understand, and I'll tell you the gaps of my understanding. I understand what a neural net is, that you have like inputs and you have outputs. Mm-hmm. So you have a certain number of neurons, and that the input neurons can be kind of crazy. It can be like an entire image can be the input neurons, and you just have each neuron is one pixel of the image. And then the output neurons can be something like, is this a picture of a hot dog or is it not a picture of a hot dog? And those two output neurons light up. So I get that. And I also understand that the inputs and outputs for the GPT APIs are working in tokens. And a token is a segment of a word. It could be a word like you. It can be a segment of a word that you use to make up multiple words. I was playing around a little bit with looking at what the actual tokens are that are generated. And for really common words like want or need, those can be a single token. But for a person's name that might be unusual, it might break that up into much, much smaller tokens. So I get that. I know that the inputs are going to be tokens and the outputs are going to be tokens. And I also know that I think it's generating one token at a time. And it's using all the previous tokens to predict what the next token is. And what I don't understand is, how is that happening? Because if I have an input of 5 tokens and it has to know the order of the tokens, does it have and there's like thousands of tokens, right? Because it has to represent all of the English language. Does it have input neurons for every single token for every number of tokens that can be an input token? So like there's one row of all the input tokens for the first token and you light that up. And then there's one row for all the input tokens for the second token and then you light that up. And then you do that for all the thousands of maximum input tokens you can have. And then the output is sort of the same. That's where this kind of gets fuzzy for me. How does that part work?
Yeah. So let's see. How much detail do I want to go to? There's 2 major ways that text models deal with this. And I'll talk about both of them. But what both share in common is you have these tokens, yes, but then you almost always go from a token to an embedding. So we talked about embeddings, right? So instead of like this, you were talking about like one hot encoding a token. So if the token is 3, it'd be 0, 0, 0, 1, 0, 0, 0, 0, 0, right? That's, I think, what you were talking about.
Hold on. I think I've lost you. What's an embedding?
Embedding.
I know you've explained this to me before and I forgot.
That's fine. Okay, ignore what I was just saying about zeros and ones. That's not an embedding. That's a one-hot thing. That's what I thought you were saying. But anyway, okay, an embedding is a set of numbers. So say you have a token. The token is like 123.
Okay.
That doesn't mean anything. An embedding is a set of numbers, say 100 numbers, and they can range. That's continuous from like -1 to 1 or whatever.
Okay.
And through training, it learns an embedding, which is sort of the meaning of the token number.
Okay.
If that makes sense. So token 120 has an embedding, which is 100 numbers long. Token 121 has another embedding, which is 100 numbers long. If those tokens are similar in meaning, then the embeddings will be similar, like in distance.
Yeah.
And if they're not, they'll be very different.
I still don't think I'm understanding this. A token would be like the number 127, which would represent something like the word want with a leading space. So I have the number 127. I'm trying to feed it in this neural net, but I don't feed in the number 127. I feed in an embedding, which I'm going to take a shot in the dark of what I think might be happening. Instead of lighting up as an input neuron number 127, I'm instead activating just one input neuron that can be any sort of variable number to what's analogous to the number 127. And that input number might be between 0 and 1. It could just be like any one of the infinite numbers between 0 and 1. And so I light it up, just up to 127. And that's an embedding, that it's like it's not an integer, it's not a Boolean, it's a float value as an input.
And it's a set of float numbers. It's like an array of 100 float numbers, or an array of 20, or an array of 1,000.
And that's like a single neuron's input is an array of floats?
So no, we'll get there.
Okay.
But yeah, so once you understand what embeddings are, so embedding, so like the embedding for want and the embedding for desire will be similar.
Yes.
And the embedding for want and the embedding for like car will be quite different.
Yes.
And so that's, first of all, how you go from tokens to just floating point, because you have to go to floating point values to feed it into a neural network, right?
Okay, hold on. So the word want and the word desire would have very different tokens. That might be like 127 and 256 or something.
Yeah.
But as before I input this into my neural net, I go from the token, which is just the number, to an embedding, which is like the deeper level abstract meaning of the concept of this token.
Yes.
So want and desire would be very close, and what that will look like is a float value that somehow specifies within the mind of this neural net the concept of want and desire kind of clustered around in the same place.
Yes. And the reason it's important to understand this is because now you have float values, which is the language of neural networks.
Yes.
Like they understand floats. So you have to get to floats somehow. That's how you do it.
Yes.
All right. So you have float values. You have a sequence of them, right? Because you have like, I want to go to the, and so you have these sort of arrays of float values.
Right.
And your question is, how do you deal with these arrays of float values?
Yeah. To predict the next token.
Yeah. There's two ways to do that. One is you can feed them one at a time. So say an array for a word is 100 floats long.
Okay.
You're going to feed it through a neural network. And you do that multiple times.
Hold on. An array for a word is 100 floats long. Shouldn't it be? So like the word want, let's say that maps to a single token.
100 floats. Yeah. Which
that's going to be 100
meaning.
floats? That's going to be 100 different embeddings attached to that single token?
The embedding is 100 long. An embedding is an array of 100 floats. Or 30 or 20 or whatever your number that is.
Okay, an embedding is an array of floats, and each of those floats is activating some sort of concept. Okay, so like yes. Desire might activate, one of the floats might be activating this internal concept of like wanting something, and another one of the floats might be activating the concept of using simple language or something.
Yes.
And then another one might be activating the concept of the novel Fear and Loathing in Las Vegas, because they talk about desire a lot.
Yeah.
But I can have any one token can map to any number of, so that there might be a million different embeddings that every token is activating.
Yes.
Wow. Okay. All right. I think I'm with it. Okay.
Okay.
Resume.
It, that was all very confusing, but it is important when you get down to it.
I think I got it.
The
I
flip.
think
All right.
I think I'm with it. Okay.
All right. So now you have these embeddings, right? One way to do it is to feed them through a neural network, just like you're used to. So you have 100 floats that represents one word. You feed it through a regular neural network, and you get out at the end what's called a hidden representation, but it doesn't really matter. And that's usually the same 100 numbers, but it's been transformed through this neural network.
Okay.
Okay, so you feed your first word through that. Then you take that, you add it to your second word, and you feed that through again. And you add it to your third word, and you feed it through again, and you go over and over.
Hold on. Okay. My input is a bunch of embeddings,
Mm-hmm.
and my output is a bunch of embeddings.
Mm-hmm.
So I take my first token of I,
Yep.
and I feed it, and then the word maps to a token for the word I, which is just a number. And then that token for the word I maps to a huge list of embeddings that are lighting up a bunch of different abstract concepts of self and
Yep.
other abstract things inside the mind of this GPT AI thing. So I take those embeddings from the token for the word I, and I feed it through the input of the neural net. So that's the input. And then I get something at the end of that, and that something is also embeddings.
Yep.
So that's going to be like, okay, you made me think of the word I, and now here's what I think about that. Here's the output of it. And then I take that, and so I have now a new array of embeddings, and now my next token is the word want.
Yep.
And so I do the same thing. I go from the word want to the token for want, which is a number, to my list of embeddings for the word want, which is a big array of float values. So now I have the output from when I previously activated the neural net with the embeddings for the token for the word I, and I have my embeddings for the token for the word want, and now I add those together.
Yep. And
you just you just add them together. you just
I say that a little loosely. There are
Okay.
many variations of this. This general concept is called a recurrent neural network because you recur, you do it multiple times.
Yes.
And so there's variations for like, how do you add them together? Do you concatenate them? Do you, there's different ways you can feed them through the network, there's different like gates you can activate to memorize like a certain number of tokens and stuff like there's a variety of tricks, but in general, yes, you take your output, you add it to your input, add being a loose add,
Yes.
and then you feed it through again. You just do that for your whole length.
Wow. Okay. So now, let's say my whole input phrase was I want pizza.
Yep.
And so I go through that whole process, and I just add together this array of float values, but it might be more complicated than adding. There's different ways to do that. And so now I just finished. I'm combining my last output with the token for the word pizza, and I feed that through, and now I get an embedding after that. Is that the start of my answer?
Yeah. And so what you do is you take that embedding and you say, okay, what word in my list of tokens is that most similar to?
Oh, of course. Because it's, okay, the embedding is like, I'm imagining one of those visualizations of the parts of your brain that are lighting up. That's in my mind what the embedding looks like. So now I need to work backwards. These are the parts of your brain that are lighting up. What token is that closest to? And then from the token you get the word. Wow. That's magic. That's really cool. That's like a brain. And then after I do that the first time, so maybe the output from I want pizza, the GPT responds too bad or something. I'm an AI. I can't give you pizza. The first embedding that gets output would be the word too, as the start of saying too bad. No, it's not the word too. It's an embedding that's lighting up parts of the brain that are pretty similar in n-dimensional space. It's pretty close to the concept of the token that represents the word too.
Yes.
Oh, wow. Okay, so now I take that one and I do the exact same thing. I feed it back through in this recurrent neural net.
Yep.
Okay, I feed it back through, and then once I feed it back through, that's going to light up a different segment of this AI brain, that's going to be pretty close to the word bad. And then I know, okay, well, of all the tokens I could pick, I'll say bad. And so now my output are the tokens that represent the words too bad. And then I just do one extra step to go from those tokens, those integer values, to the words too bad.
Yep.
Wow. Okay. I get it. That works very differently than I was thinking it does.
Okay.
Thank you.
So,
great. I understand this so much better.
Great. So you get it. That's not how GPT works.
Ah, come on.
It's an important building block to the
Okay.
step. Okay. Now, instead of that, it turns out there's lots of problems to that. For example, if you feed 1,000 words through that, like how are you going to remember, and specifically, how are you going to train all the way back to the first 1,000?
Yeah, because my signal from the very first word is going to be totally muddled. And okay, yeah.
Exactly. And you could only look backwards as an example, whereas sometimes you want to like see a whole sentence and detect a word in the middle. GPT also doesn't do that, but there's a class of problems that do that.
Repeat that last one. If I have a
So
whole
like
sentence.
say you want to see the sentence, I really blank pizza.
Yes.
You have to be able to go look forward and backward. Recurrent neural networks can only look backward.
If my input is I really blank pizza.
So in a recurrent neural network, you'd feed I really, and then you get a blank, and that network doesn't yet know that you're going to say the word pizza because you have to feed it forward in time, basically.
If I want the neural net to fill in something in the middle of a sentence, that wouldn't work with a recurrent neural network. Is that what you're saying?
Yeah.
Okay.
So anyway,
yeah, that makes
the
sense.
training problem, the middle problem, those are the reason sort of that this new class of things was created called transformers.
Okay.
So if you hear about transformers, that's how all the latest and greatest language models, I guess, work. What a transformer is essentially, imagine that RNN, right, the recurrent neural network, but instead of feeding it one at a time, you just unroll the whole loop. And so you have all your tokens now. And this is where it gets a little weird because you have to pick a size. So that might be like 1024. It might be 32,000. There are different tricks also to get different sizes, but you have to pick a size. So you say, I'm going to feed you 1,024 tokens at once.
Okay.
And that's basically what you do. If your sentence is, I really like pizza blank, then you would feed it the embeddings for I really like pizza. And then you would have a bunch of like null embeddings.
Okay.
Or you might have a bunch of null embeddings and then at the very end say, I really like pizza. Depends.
Yeah.
But yeah, that's how you do it. And then you predict the next embedding. And essentially the same process, all it's very different internally. But that's basically how all these latest and greatest LLMs work, is they have unrolled these recurrent neural networks.
I don't think I understand. So let me try to explain that back, and you tell me where my gap in understanding is. Instead of what we just talked about, which is you go from the word to the token to the embedding, and then you feed the embeddings one at a time, and recursively, in a loop, you feed it back in on itself. Problem with that is, by the time you get to the end, you're going to forget what the first word was, because it's your signal is only being maintained in that one variable of every time we loop through it in this array of embeddings. So instead of doing that, GPT and all the cutting edge things doing this are using transformers. And transformers, a limitation of it is you have to decide what the maximum length is of your input from the beginning. Yep. So this is why all these GPT APIs have a token limit. So you might say the biggest question you can ask us is going to be 1,024 tokens long.
Mm-hmm.
Okay, 1,024 tokens long. So what that means is I'm going to give you as input an array of embeddings, where an embedding is an array of floats. So I have an array of floats. So I'm imagining like a two-dimensional matrix where every row is an embedding, and then every row and column is one particular float value. And now that's the input to my neural net.
Yep.
So now I'm feeding it basically that I'm just blasting the entire sentence all at once on this brain.
Yep.
And now my output is still a single token.
Yes.
Okay.
It can be there's lots of different things. So depending on what you want your network to do, you can output an entire sentence. So you could output 10 or 1024 tokens if you want.
Sure.
So like if you're translating from English to French, maybe you have 1024 inputs, you want 1024 outputs.
Okay.
As an example. But the way generally that they work is, you have a single output, which is the token that it's predicting next.
Okay. So if I'm doing that, if I just get, or it wouldn't be a token, it would be an embedding, and then you see what token is most proximate to that. So if I do that, if I'm feeding it and as input an array of embeddings, and then I get as output a single embedding, I could then take that output embedding and add that to my array of input embeddings and then get the next token. And now every time it's getting the full context of everything I'm saying.
Yep.
Excuse me. It's getting the full context of everything I'm saying. So it's like the signal's not muddled. It's not going to forget the word that I said at first because it's still receiving as input the full signal of the first token that I said.
Yep.
Wow. Okay. I feel like I just blasted through like decades of AI research. That's so cool. And I see why we started with the first step. That was much simpler to understand. And wowee, what a great solution that you can just explode the number of inputs you have. Yeah, cool.
And if you did that naively with a single neural network, you would overflow all the memory in like the supercomputers of the world.
Sure.
So there's lots of tricks for how you can feed in something as long as 1024 embeddings, which might be 1,000 floats themselves. They're not, but they could be. So there's lots of internal tricks to transformers, and there's reasons why they're really cool. One reason, this is sort of separate. You don't have to understand this part, but one way that they're cool is like internally, you can't rely on the order of the things because of the way they work. And so in order to know which token comes first and second, you have these things called position embeddings, which are again embeddings, the same length as your input embeddings, but you just want to know the position of the thing. And so you have a bunch of sine waves that overlap. And so you have like a long frequency one and a short frequency one and whatever. And you add all that up into an embedding, and then you add that to the token. And then you can mix up all the tokens all you want, but you know what order they came in because you have these overlapping frequencies of sine waves.
Oh, interesting.
So it's something that's kind of cool. Like that's one of the tricks.
I don't understand what you said about the overlapping sine waves, but I understand the purpose of that is that now every embedding has with it the context of the position that it is in the string.
Yeah.
Wow.
So the sine wave part is like say it starts low and goes high, and it's high at the very end.
Right.
And so if your position embedding is high, then you're in the second half of the sentence, and you just have multiple frequencies of those.
Okay.
And so you get finer and finer grained.
And you have enough frequencies that you can identify. I guess I don't understand why we're using a sine wave instead of just an integer index, but
you could use an integer. Yeah, people chose sine waves because,
probably easier at some technical level
because they're continuous. Yeah,
because they're continuous. Yeah, that would make sense. Okay. Wow, cool.
Yeah, so there's lots of tricks like that. You can look up videos about transformers if you care.
I do. I'm in this now. I feel like I understand just enough that I would be able to slot in more stuff that I learned in the context of what the overall functionality of this thing is. Okay, cool. Thank you. I know about ChatGPT now. I think I'm curious for someone like you who knows so much about the internal workings of this. Are you using ChatGPT in your daily life? Do you use like the codex thing for code completion? Do you ask it questions?
Actually, no. Which is funny. It's sort of a cobbler's shoes cobbler's kids have no shoes situation.
The
I think
cobbler's shoes have no kids.
yeah. But yeah, I have not yet found it to be super useful, which is very interesting to me. I think I probably could force myself to use it, and then I would probably find it useful. Like I've heard that Copilot is super great. I just don't use Visual Studio Code, and so I don't use it.
What do you use?
Sublime Text.
I also use Sublime, and there's a hacky way now that you can get Copilot to work in Sublime. And I installed it, and there's a free trial. It's like a 30-day free trial from GitHub. And it's this library for Sublime called LSM or something. And I don't understand what that is, and it's not as integrated as it is in Visual Studio Code, but it does what it says on the box of it'll suggest code to you. And I did it kind of skeptically because I saw some demos and was like, well, this is cool, but it's not going to be that good. And I started using it, and it's been so long since I have used a coding tool that just seamlessly improved my productivity by, I don't know, 10%. Because here's specifically the context where I think it's super useful. There's a thing I need to do to write a really basic function or to make a really basic API call, and I know roughly how to do it. Something like, oh God, finding subarrays of, based on an index in JavaScript. I don't know what it is, but every time I try to do this, I'm like, is it zero indexed or it's dot substring, but is the first one's inclusive and the last one's not inclusive, yep. Something like that. I don't remember. Hard. So in that sort of context now, working with LSM, working with Copilot, I type a comment that says, split this array into a piece from index this to index this. And then I hit enter. And then I wait about a half a second. And then it pops up with a suggestion saying, oh, is this what you want? And I'm like, wow, yes, that's exactly what I want. And then I hit tab. And it's not like groundbreaking, life-changing. It's just enough of an improvement to be kind of spooky, where I'm like, oh, this could get really good. This could get to the point where I could just tell it what I want, but it's not quite there yet. And every once in a while it makes a silly mistake. But for the situation where I would have in the past Googled something and then not gotten great results, and then Googled something slightly different, and then looked on Stack Overflow, and then realized, okay, yes, this person is asking exactly what I want, and then scrolled down to the answer, and oh, that's not quite right, and then scroll down to the next answer that's not the approved answer, but it has the most upvotes, right? And then, okay, that's the thing I want. Let me copy that and paste. Oh, but the variable names weren't right, so let me change the variable names. Instead of doing all that, I now type the comment, and it knows all the context of my code magically. Every once in a while, I get really surprised. It performs better than I think it reasonably should. It'll anticipate a bug that I wasn't thinking about. That's when it gets especially spooky. So like in those moments, in what I was doing previously, that would have taken me, I don't know, 3 minutes, and now it takes me as long as it takes to write the comment, which is shorter than I would have Googled it. So it takes me like 20 seconds. That's not all of coding. There's a lot more of coding of thinking about higher level architecture, and there's a bunch of people talking about, me included, talking about how like, oh man, our coders' jobs are going to be secure with improved versions of this thing. And I think for the medium term, it's just going to make coders more effective. And I heard something recently about like the probably what's going to happen is that the world's appetite for software is just going to go up. Every coder is going to be able to be X times more effective. Right now it's 10% more effective, and that's going to keep compounding and getting better. And what that's probably going to mean is just everyone's going to want more software. Everyone's going to want more custom apps. Businesses are going to want more stuff, and the cost of software is going to get cheaper. And but I've gotten off track. The core thing is like Copilot's really good. I was skeptical of it. I adopted it way late. I started using this like maybe 2 or 3 months ago, and I would highly recommend it. And you can use it on Sublime.
Cool. Yeah. So a few things. One is that sounds perfect for things like, I think my example I always go to is saving and loading PyTorch models. Like the API is slightly different for saving and loading, and I never remember which is which. Yeah. And so, yes, if I could just type a comment, save the model, and it outputs the line, that would be awesome. Yeah. Because it keeps you in your flow instead of, breaking you out.
Exactly.
So that's really cool. Second, this is definitely going to help coders in the short term. And now, and even when I was consulting, a lot of my job, so it was coding, but it was also like sit in the meeting with the executive and the project manager, and they talk, and then you turn that into code. Right. And eventually AI will probably do that. But like, it's going to take a while, I think. Yes. Like for, AI to be able to turn entire meetings into working code. Yes. That can rely that like a healthcare company can reasonably go to their lawyers and say, yes, this works. Yes. To get insurance. That'll take a while. For sure. So, and it's wild to me that we're having this conversation that like, if you had told me 10 years ago, hey, you're going to be in this future world where computers can just write code for you based on comments that you write. How do you think that's going to change your life? I would have been, oh my God, that's incredible. Like, is this a conscious AI that's, have we hit on the general artificial intelligence? And
oh, do you have robots that walk around and like do stuff for you too? And it's so interesting to be in the middle of this revolution that I'm on the exponential curve, just rocketing into the moon. But yeah, like I can totally see how on the trajectory that we're on, we're going to get to a point where you can just have a robot sitting in a meeting listening to what people are saying and then be able to generate the code for you. And even in that world, I think you're gonna have human specialists who are a little bit better at doing that. Like even with ChatGPT, it's a skill to learn of how to interact with this thing, and prompt engineering is like its own thing. It just feels like this evolution to me of having tools that make you more capable and going from assembly, going from like punch cards to assembly. I'm sure there were people around at the time who were like, coders aren't going to exist anymore because any old schmuck could learn assembly, and like this isn't like back in the old days where you had to have all the technical know-how of how the punch card machine worked. I think I got a little spooked for a little while, and I think I'm starting to see this more as just a continuation on the spectrum of having working at higher levels of abstraction.
Yeah, and the trick is, it's almost certainly not an exponential; it's an S curve, like almost everything is. And when you're on the exponential part of the S curve, you cannot tell where the top is.
Yeah,
and so it might be that AI gets really, really good, but in meetings, like with executives, it fails just enough times where executives don't trust it.
Right.
And then it will never be used to write complex software.
Right.
And there has to be some other thing that does that, which will take, 100 years. We don't know.
Yeah.
So yeah, everything looks crazy now, but there's going to be a top to the S curve. And maybe that top is artificial general intelligence, but I kind of doubt it. I think there's going to be a top before then. And they'll have to be something else.
Yeah. There was a fantastic interview between Lex Friedman and Sam Altman that came out a few days ago where Sam Altman's talking about all these questions of like that's my podcast recommendation. Watch that interview. That's
on my list. I want to watch that.
That's really good. He's talking about all these questions of, is ChatGPT 4 general AI and general artificial intelligence? Yeah.
Artificial general intelligence, AGI.
AGI. That's right. Thank you. And Sam Altman's perspective is like, I think it's like absolutely not, but he's also really curious about other people's perspectives on it. Because like all these philosophical questions we've had for so long of how do like the Turing test and how do we know if things are going to be conscious, like those the things that we used to talk about are starting to slip. Like this thing can very passably pass a Turing test, and so now we've just sort of moved the goalposts of like, well, when it can sit in a meeting and be able to write code from that, that's when this is really going to be spooky. But yeah, I think I'm starting to feel like an old man. Like I'm ready for this to start slowing down. Like I feel like there were a couple days last week where every day there was a new announcement of, oh my gosh, the GitHub from Microsoft announced a whole bunch of things in betas of new integrations with Copilot, and that came right after GPT-4 was like a few days before that, and it's I would like to
Bard came out.
Say it again.
I said Google Bard came out. I have
Google
to
Bard.
As a chill now.
Yeah.
I have to.
It's just a little too much for me. Can we slow down just a little bit? Just give me like a month between these updates.
Well, I talk about the S curve. As someone who reads papers that are coming, there's at least one more shoe to drop, which is video. So video is coming quickly.
Yeah.
This last week had 4 or 5 different state-of-the-art video papers come out. So text to video is coming.
That's wild. That's something I'm excited for the video clipper, which may be a good transition to talking about that. Man, we got real in the weeds of ChatGPT. That was great.
I had one more thing to say about prompts, which is I talked to a friend recently. So I don't feel like I use ChatGPT very well. He hasn't fully embraced it. And he talked about like how he uses it. And he uses it sort of like a back and forth thing. And he'll say stuff like, I'm thinking about building this system. And he told me the prompts that he was using, and they're much more detailed than anything that I put into ChatGPT, which is, I think, something you have to do. You have to learn how it works. And then this prompt engineering thing is a real thing, like how to get the output you want. And so he spent enough time that he knows sort of keywords to use to get the right output. And then he'll say, oh, and then tell me about this thing. That's interesting. Tell me more about whatever. And the prompts are multi-sentences long.
Yeah.
And I think if you get good enough, that's when it can be really helpful, when you know what prompts to use and the keywords and
Yep.
how to respond. Yeah, and I'm just not there yet. So
Yeah, it's a
yeah.
skill. I'm craving more educational material on it. I'd love to take a course on
Yeah.
how to do this. I took one that was much more focused on making content, and I feel like that gave me a lot of insight, like seeing the prompts that were used and the level of detail and the things that were possible was really interesting. But I want more of that. And that's another funny thing from the Sam Altman interview was Sam Altman said that he's really bad at prompt engineering, which I thought was funny for someone who, you know, is the head of this company and like is running this thing.
Yeah, he's probably too in the weeds. Like, you know, he's
Yeah.
worrying about how big his transformer is, not how to prompt engineer.
Right. And hiring and firing and that sort of thing. Yeah.
Yeah, probably more of that. Yeah, that's true.
Yeah.
Cool. Video clipper.
Video clipper. Yes.
Yeah.
I'm really excited about the automated video stuff because I feel like that's going to be able to feed directly in. But I have some updates for you. Last week, my brain was kind of on fire. I was feeling a little manic with all the possibilities. And last week, I feel like I had a really solid week of execution. And I find myself in these moments of like wanting to get stuff done faster and getting thrown off a little bit by finding out that there's another competitor in the space and they're backed by Y Combinator, and like, oh, okay, let's slow that down a little bit. Like, I'd love to have some more time to do this, but then I meditate and I center myself again and think like, okay, I'm not trying to take over the whole market. I'm trying to get to 20K MRR, very reasonable. There's a segment of the market that's going to be people who I can be providing the best value for. Yes. So, I had a clip finding breakthrough. This idea of trying to find clips with AI. I was talking last week about how I'm going to try to use the ChatGPT API to do this. And in the process of getting better transcripts to be able to have better output with ChatGPT's API, because I tried it on just the automatic YouTube things and it wasn't great. It was kind of weird. So I went to back to Assembly and was reminded that they have automatic chapter recognition. Right, they can tell you like the segments of the video of when different chapter ideas start. And so I looked at that and I realized, oh my gosh, which was the idea I had like a month ago. This is perfect. Like every one of these chapters has in it a really good clip, and the titles for it were just banger. The titles were really catchy, concise, interesting stories. And then somewhere in that segment, so that's just like a start, stop time, and a title. Somewhere in that segment is a really good clip. So that's a really good starting point. So that's now part of this flow. And then this next week, I'm going to work on tightening that up. Given this segment of the transcript that has this idea as defined by this title, cut out all the unnecessary words. And that's a really, that's a much more straightforward job for ChatGPT to do. So
that's probably also within their token limit now.
Yes. Yeah. And much more predictably, because it's, you know, a chapter is not going to be 2 hours long. A chapter is going to be a maximum of like 10 minutes. So yeah, that's going to fit even in the smallest token limit of the like ChatGPT 3.5 API. So that feels really good. And then the output of that is smaller than that. So yeah, it just makes a lot of sense. I had a bunch of bug fixes. I made new templates. I'm just like every time I go through kind of smoothing out the whole onboarding process. And I feel like I have this clear idea in my head that I talked about last time of what the ideal onboarding flow is going to be. Followed up with people from the conference, getting YouTube videos from each of them. And these are all now marketers, which I feel like is focusing me on this as a niche. And I don't feel like there's a lot of competitors in the space focusing on marketers as a customer. So that, like, I feel really good about that. If I can really nail the use case for marketers and all my copy is directed to marketers, and that feels good. I feel like a lot of people are going to go after influencers, and that's part of why I was excited about this at first, because that felt like audience that I was excited to serve, and felt like it was really easy to get in contact with them. And that's where I see everybody going. So yeah.
If you're raising money as a company, you probably have to talk about how you got Gary Vee to use your system, right? You know, so yeah, you can go for more niche for sure.
Yeah. I want to talk about how I got Leslie, who has 4 marketing clients, and I'm getting her to pay me.
She's paying $99 per month for each of them, right?
Right.
Or total. I don't know. However your pricing works out.
I also don't know. I'll see how my pricing works out. Yes. Talk about marketing. Oh, I was reminded of what a good tech stack it feels like I have chosen. that works
This
well
is
for me.
Firebase with Lambda functions.
Firebase with
Sorry.
serverless functions, yeah. Because I had on my to-do list that one of the things I want is to be able to send people notifications when they've had clips processed, especially after they've uploaded a new video. And so a subtask of that is, okay, well, I have to be able to send SMS messages and I have to be able to send emails. And I did both of those in a single Pomodoro of 25 minutes from nothing.
Nice.
Because sending emails is just a Firebase extension. You hit a button and it installs and you enter the SMTP details. And I'd already done that once before, so I just added those. And then to send an email, you just add a Firestore document and then it takes care of sending it and keeping track of the errors. And it was exactly the same thing. I'd never done this before, but it was exactly the same thing for sending text messages. You just install the extension, you enter your Twilio API details, and then you just create a new document that has a to number and the body of the message. And if you want to, you can add an attachment that's just a URL to an image. And then that just worked. So that was like the most productive 25 minutes that I had all last week. That was pretty cool. What else? For next week, I'm still just working on smoothing out this flow. I'd like to be automatically pulling YouTube videos, like long polling, checking every 12 hours or something for every channel. Do they have a new video? And then I would like to connect that with this flow that I have now of getting the assembly transcription and getting the chapter markers. And so then I can send a notification email that says, hey, you just published a new episode, and here's 4 clips that I recommend from you for this episode, and here are their banger titles. And then once they land on that page, I think I want to do this manually. It doesn't make sense to do it manually. Also in the background, I'm going to be tightening them up with GPT, and I think I can get there this week. And then if I have extra time, I want to work on the onboarding flow from the beginning, which is going to involve rewriting the landing page. I love your idea that you said last week of that they don't need to add a password, and that's going to be technically challenging to do. So I don't know if I'm going to ship with that, but my gosh, how nice would it be if the only thing they did was enter an email and maybe a phone number, and then I can start sending them emails that say, hey, this new thing is ready. You can click this button to download it, and they already have an account.
So the trick is just set a random password. When they enter their email, make a regular account, set a random password.
And then just send them a magic link to log in. If I'm sending them a URL that's an authenticated URL, I think ideally what I would want is in that email, if they click it within 30 minutes, it's going to log them in. But if they don't click it within 30 minutes, it expires and it takes them to a page where they have to log in. And on that page, they can either, I think on that page, I just do a magic login where they can say, like,
that's
this link
rough
expired.
Because
I'm going to send you another.
they click a link in their email, then they go to a page where they have to be sent another email.
Yeah. It's a better flow in the beginning because they don't have to give me a password. I don't know if I want to do this. I think I just want to make him sign in the regular way.
Right.
It's going to be a little bit more friction in the beginning, but then it's going to be less friction later on. Actually, yeah. Especially after the first time they're getting a clip, they're going to, I think, feel a little bit more motivated to do this because they're trying out a new tool. Sure. They want to see how it works. So if my flow is, you give me your video, I ask you for your email and maybe phone number and tell you, okay, I'm going to email or text you when this is ready. And then you're waiting for that, and then you get it, and then you click on it. And then I show you the thing that you want. But if you want to download it, I say, hold on, you just got to click this one extra button that's authenticate with Google. Or if you're an email password sort of person, come up with a password. But that's just like one extra click. And then once you've done that, now you can download them. And now I have an account for you with the password saved in your password manager or authenticated through Google or whatever else. Yeah, I think that's what I want to do. Okay. Cool. Glad we're in agreement. How much time do we have? 6 minutes. I'm going to go rapid fire. I just have a couple of short things I wanted to say. I remembered this practice I've been doing called CEO walks, where in the morning, first thing, I walk around with an app called Otto. I think it's Otto.ai. that's just doing voice transcriptions. And I walk around with pretending like I'm talking to a person on the phone. I have like my earbud in with the thing, but I'm just rambling to myself like a crazy person. And I added to this, and I'm talking about like what I want to do for the day. And I added to this process that I can take that raw transcript now and enter it into ChatGPT and say, hey, summarize what I need to do for today based on this rambling. And it does. And it doesn't do it great, but it gives me a great starting point where then I can go and say, oh, well, yes, that's what I said, but actually I would phrase it this way now. So yeah, that's been really cool. I finished making a tabletop, which is a project I've been working on with Sarah for months, and it looks really good. Learned how to join the wood, and this is my backup career if AI decides to take all our jobs. I at least know I can
for a
make
kitchen
tables.
table or
A kitchen
something
table,
else,
yeah.
coffee table. Nice, very cool.
Yeah, and it looks like a real table.
This is very woodworky, but what kind of finish did you use for a kitchen table?
I used gel stain that Sarah found that stained the pine like this nice like dark oaky color. And there's a thing you have to do in that so that the stain goes in better, and then you wipe that off and do it like 3 times so that the stain is set in. And then once that's dry, I put polyurethane on top of it, and then you do 3 coats of polyurethane, and it feels like a table. Like I feel like I made something professional. It feels really good.
Yeah, I was just wondering because kitchen tables like take a lot of abuse. And
yes.
So I was just curious.
Yeah.
I'd be curious like in a year if it holds up.
Yeah, so will I. Sarah did the research for the finish part of it, and polyurethane is what they recommended, and it's hard. But it said it took like 3 days to fully cure. So
the nice part is too, like if you mess it up, you made it, so you can fix it.
Right.
Like you can always sand it off and refinish it.
Yeah, exactly. So that feels pretty cool. I also this weekend picked up this project that I talked about forever ago called Where Did My Money Go? This is such a bigger story. I'll say it really quickly. One of the things I used ChatGPT for was working on this project because I got stuck with Plaid, the AI that is able to API that's able to fetch bank details. They told me that I had like a sandboxed environment, but the sandboxed environment wouldn't let me authenticate actual bank accounts. So I applied for production access, and then I was able to do actual bank accounts, but I wasn't able to do it with Chase because they said, oh, for Chase, you need to fill out this form that says that you are doing all these extra security things. And one of the 20 questions on there was like, attach your company policies for what to do if there's a security breach or something. And I was like, I'm one dude. Like what? Or your policy on doing background checks with contractors. And I'm like, this isn't relevant for me. I feel so frustrated with this. So I was stalled on that for months. But then I remembered, hold on, since I was stuck on this, ChatGPT came out. So I just typed into ChatGPT. I just copy and pasted exactly what their description was of the document they wanted. And I said, like, this is for a company that does finance tracking and has to authenticate with bank accounts. And Chris, it spit out the most beautiful garbage I've ever seen in my life. It's all the legalese of, it's just perfect. And it's subsections in different chapters and talks. And there were just parts of it where it said insert company name. And so I just took that and I copied it and I pasted it in a markdown file, and I used Pandoc to turn that into a PDF, and it looks so good. It's just, I didn't even read it. I replaced all the times where it said your company name with my company name, and it was like 6 of these documents that I had to do. But it was great, and then I was able to send it in, and then the very next day I saw that I had approved access for Chase, so I was able to figure out for Sarah and my accounts like how much money we're spending per month and where that money's going. And then I saw that they hadn't even looked at the documents yet, so I think what might have happened was they approved it earlier, somewhere between when I worked on it and now, but I didn't check before I did the document, so I don't think I actually needed to do that. But it's cool to know that I can do that. That felt like a really good use case.
Yeah, oh man. The end game for all of this is so weird because like at some point an AI will read those as well, and make some determination. And so this reminds me of like this picture I saw, which is like a human will talk to an AI, which will send some information into a system, which will talk to an AI, which will spit out something to a human. And that's how we're going to talk. Yeah. Just talk to the AI, which will interface with another AI. Yes. Oh boy. Yeah.
My wife and I think would benefit from a system like that was translating for both of us what the other one was saying. We've had some moments recently where I after working through it, I totally understand that Sarah was working to communicate something to me very clearly. And from her perspective, It was a very clear request, but I did not hear the request. I feel
Yeah.
like women use a different language than men do. And so if there was just an API between the two of us that was just an AI translating, like hearing and empathizing with my wife and like, oh, that sounds really hard. And then to me, it was just like the one sentence of like, you need to take out the trash. And then, oh,
Yeah.
okay. And then it translates that to my wife of like, oh, I'm so sorry. And I'm happy to do that in the future. And thank you so much for reminding me.
Oh, man.
Yeah.
So a few things to say about that. One is as you progress and eventually you stop caring as much and you just say the thing, or two things happen. You learn the other person's communication language.
Yes.
So that happens. And then you also just are more direct because you don't have to care about the other person's feelings as much, I think. But that's probably going to happen. Like, you're
For
probably
sure.
going to have microphones on all the time at some point. And, you know, like if an AI tells you, hey, dummy, take out the trash,
Right.
like that feels okay. Whereas if your wife said that would feel like an attack.
Yes.
And so absolutely that's probably going to happen.
Yeah.
Oh, man. It's like the movie Her, but with a real person.
Yeah.
You know?
Oh,
And
yeah. Yeah. I think I'm okay with that.
I mean, yeah, kind of. Like, people miss social cues all the time. And if you had an AI helper that just said, you know, like, hey, she's telling you to take out the trash.
Yeah.
Just do it. She'll be happy. Okay.
Yeah. This would be a really good like SNL skit.
Yeah.
I'm reminded also of this idea I heard before of what lawyers and the tax department at the government are.
Mm.
And it's kind of like an apologies to anyone who works in either of those fields, but it's an army of bureaucrats, and you need your own little army of bureaucrats to interact with the other army of bureaucrats. And if we could somehow remove the middleman and the government just says, hey, pay us this money, and then I say, okay, and I pay them that money, that would be much simpler. But because of now there's this cat and mouse game of like, because there were some rules and some exceptions, now it just sort of balloons, and now the person with the most bureaucrats wins. I see the sort of situation where you have armies of bureaucrats on both sides. I really hope that that gets replaced with more AI in exactly the same way as I used it for this Plaid API thing.
So, like, lawyers and even the tax department are, I think, sort of an extension of the tyranny of the commons or whatever the thing is, which is like most people are good most of the time, but 0.1% of people are going to just fuck everything up whenever they can. And so you need lawyers and you know, tax people with you know, who can go after you and arrest you because of those 0.1% of people. And they make it scarier for all of us. But without those, like, it'd be anarchy.
Yeah.
Because of the 0.1% of people, you know?
Yeah, I totally get that.
Yeah.
Tragedy of the commons.
Tragedy of the commons, not tyranny. Yeah.
I wonder how, like, because those people are also going to have access to AI. How's this going to shake up?
AI for evil, man. Yeah. If you have access to AI, you can use it for evil.
Yeah. I feel like we're just going to, it's going to be exactly the same problems. It's just going to be magnified. Huh. Well, I think the best thing for me to do as an individual is get really good at prompt engineering and get really good at using these tools. Have my own army of bureaucrats that's bigger than anyone else's and more effective.
Yeah.
One last thing, which is, in the process of doing this, I ran into this problem of when you copy text from the ChatGPT API, it removes formatting on lists and things like lists, bold and italic and all that. And so I made a real quick Chrome extension to copy it as Markdown, which is like find the div, find all the document, and then use this library to go from HTML back to Markdown. And that worked great.
That's cool.
And there's one Chrome plugin that does this right now, but it's not very good. And so I think, you know, in a spare 2 hours I think I'm going to release a plugin for this and just see what happens.
Release a plugin, make a blog post, and post it to Hacker News. Yeah, for sure.
Yeah, cool. I will. The search volume for this is abysmal. No one cares. No one else is trying to cut. They're just like...
it's the type of thing that I wouldn't think about until I saw it on Hacker News. Then I'd be like, oh, that's cool.
Yeah.
And so you'll probably,
All right.
You know what I mean? Yeah.
We'll see what happens. Chris, that's all I got.
That's all I got.
Then I'll see you next week. Goodbye.